thank you very much for coming along today. It's really lovely to hear lots of questions and to see our technical team and Darren with people who've got questions they want answered, and you can hear, you know, real learning taking place and new skills being transferred, which is great. And you know, we've really missed these in-person events, and you know, online seminars are really good for a quick getting started, but there's no substitute for spending time, I think, with colleagues and sharing a problem and immersing yourself in a subject. So thank you very much for sparing your time today. I want to say a bit about the university program, which just really puts this course in context as to what we're doing overall. Before I do that, I'd like to thank Ding Dang Digital, who are videoing our course here. Yiting Chen, who's actually sitting out to the front, working away. She helped organize most of the event today. With her is actually her successor, who's going to, because Yiting is with us on a placement, and will finish her placement in July, and she'll be handing over to Jinyang Liu, who's sat at the back of the room. He will be the new University Program Marketing and Business Assistant. One of our former students is here, who helped organize the video and some other aspects, and that's Jackie Chin, who's sitting there as well. And you may be thinking, they all sound Chinese names. They are all Chinese, and the reason is because this is a global program, and we want to make sure that we can communicate just as well with our customers in China and around the world as we can with our English customers as well. And obviously a big thank you to Darren. Darren has been associated with our program for quite some time. He wrote the first set of these materials some years ago, came back, updated them. He expected to do this workshop in June of 2020, and of course it got postponed. But finally, we're running the workshop and we're capturing the video that we wanted to. So thank you to all the people who made this possible. Next slide. Okay, a bit about imagination, you know who we are. We're a medium-sized company, about 900 people, headquartered near Watford in Kings Langley. Our primary business is GPUs. And our graphics processors have been embedded in mobile phones and tablets for many years. We were a pioneer in this business, and we're still very much the reference in terms of our development tools and the performance of our GPUs in mobile devices. But we've been expanding also into other businesses, which I'll mention. The GPU business was dominated by mobile devices for many years. We have a growing presence though now, and I saw the other day on an analysis that about a third of our business is now coming from automotive. And that's GPUs embedded in dashboards and in-car entertainment systems. And that's taken more than a decade to establish that business, because if you want to put a GPU in a car, you've got lots of approvals to go through. It takes a long, long time. But we have a very commanding position now emerging in that area. So our GPUs are finding a growing usage in the motor car. And there's probably a 50% chance that if you've just bought a new car, that there's an imagination GPU either behind the entertainment system or the dashboard or both. We're also beginning to see our GPUs being pulled into data center type applications for AI activities. And that is a growing business. Some of our GPUs also now finding their way into lower end PCs. And that wasn't a market we originally targeted, but power consumption and battery life is important to everybody. And by using our GPUs in PCs, you can extend their battery life. And so compute as a subject, not just graphics, but using processors, originally starting with graphics processors as compute elements, has become a key part of our business. And so using GPUs as compute engines for AI and other applications, augmenting that with neural network accelerators, and indeed across this year, you'll see us begin to introduce CPUs as well. So we're trying to come up with a comprehensive solution to compute needs whether they're for graphics or for other applications. Next slide. How do we make our money? Well, very simple. We're like architects designing homes. You can buy a plan from us for a chip, and you pay a license fee for that chip, and just about every famous semiconductor company in the world has licensed some IP from Imagination at some point in the past. Once you put that design into your chip, every time you make a chip, we get a royalty. So our revenues come, and this year we will turn over about $150 million, and about a third of that will come from royalties on chips that are being in production and being shipped now, and the rest will be from new licenses. And so our primary customers are companies that design semiconductor devices. And obviously, though, we need to talk to all elements of the cycle. So we talk not just to the people designing the chips, but the people that are designing the end equipments. And Omar, for example, is spending quite a lot of time working with games engine people, because there's always new things coming in graphics, and making sure that we have the right tools and that our future chips will support new innovations like ray tracing, which are features that people want. We need to make sure that we're talking downstream and we can see what new demands are coming. So that's how we make our income, is of selling licenses to designs and getting royalties on the shipment of chips. Next slide. And there's a lot of chips with our IP in it, about 11 billion when this slide was written. So that's a lot of appearances of our designs. And you know, it takes a lot of people by surprise when you talk to somebody in the States or in China and say, do you realize it's a medium-sized British company near Watford that has designed the graphics processor that you use every day? Very few people are aware of where that technology came from. When this slide was written, these figures I think are about 18 months old. 36% of all GPUs are from us, and we've been gaining market share recently. And nearly half of all automotive GPUs have been designed by Imagination. And our 2020 revenues were 125 million. Last year was about 150 million, and we expect to grow again this year. Some of you may be aware, we're on a recruitment drive. We're going to recruit 250 people this year, which will be the largest new addition to the workforce of Imagination. Most of those will be in the UK, but not all. Some will be in Poland, Romania, China. These are places where we have development centers. And some of our customers, you'll recognize some of the names there. And people like MediaTek, who make chipsets for mobile phones. They're a Taiwanese company, very large customer of ours, use a lot of our GPUs. Renesas make chips for automotive. They're one of the key companies that use our GPUs in their design. And Texas Instruments, another one, making chips for automotive applications. And the BeagleBone board that we're going to give away later today, which has a TI piece of silicon on it, that was designed and made by TI some years ago and turned into an open source community board. Next slide. So quick bit about the university program. Why does Imagination have a university program? Next slide. It's about creating a community of users, primarily in academia, although in the last few years we've begun to see pull from individuals who want to know about our technology, and also from companies who are sometimes using these materials for in-company training. And in fact, some new recruits who come into Imagination are actually using the university program materials. So we have some internal use as well. So although the materials are written primarily for teachers to use with students, the applications are not restricted to that. And so if it's important, if a company wants to use these for in-company training, they can use our materials. The only restriction, we own the copyright on the materials. The only restriction we put on that is the usage should be not for profit. You know, if you wanted to take all our materials and put them in a book and then sell the book, we'd like you to ask us first. If you wanted to run your own workshops and charge for admission, we'd like you to ask us first. But for academic use, there's no restrictions. If you want to share the materials with your students, copy them, make your own workbooks, whatever suits you for academic use, we're delighted if you're using our materials. That's the aim. And we don't want to put any barriers in the way that make that difficult to do. So it's just some pictures of some of the activities. It's a global activity. I used to travel very extensively. I haven't got on a plane since March of 2020, but I've just found out I will be going to Paris, to RIS5 week in Paris at the beginning of May. And we have workshops in the United States coming up in May. Which I'll be attending in Las Vegas, of all places. So obviously with the boss, when you put in a requisition to travel to Las Vegas, it takes some justification because it looks dangerously like a freebie, but it's not, it's work. So, and then I'll be going up to Silicon Valley. And we run some activities with student societies, particularly to help the recruitment. So in Bristol University and in Cambridge, and at Imperial College, we are sponsoring student societies there to help encourage the people to take an interest in perhaps a career at working at Imagination. Next slide. So we have a business objective. The university program is not here just because we want to be good citizens, you know, and we need to be because we're recruiting a lot of people from universities. So it's quite important to put something back in for that contribution that universities are making to our success. So we want to invest in things that are useful to universities, but we're also doing this because there's a good reason. We all know that people like to use what they know. And, you know, in China, you can get Microsoft Office free of charge if you're a student. And that's very successful because it means every Chinese graduate, they know Word for Windows, they know PowerPoint, they know Excel. If you say to them, look, there's this free package you could use, it's just as good, they'll go, no, I'll use this one because that's what I know. Well, we want to do the same thing with our technologies. So today, you're touching Vr Sdk. Obviously, I'm biased, but I believe that that is the best package of its kind for graphics developments available today. In fact, I'll let you into a secret. Some people use Vr Sdk and then they have the nerve to take the output of their work and then port it onto other people's GPUs. But the work still begins with our tools. Why? Because they were the first, they're the most developed, they've got the most powerful debug tools and so on. Development tools are a very key builder of loyalty to a company's products. And what I want to do is to help us create more loyalty amongst the next generation of designers. So if we're successful in helping you as teachers to use our technology, you'll share that with your students, and your students may become future customers. So you've actually let a salesman in to talk to you today, although you didn't realize that. But if I'm successful, it'll create business 5 to 10 years down the road. But there's a good reason to do this. So for that reason, don't be shy to ask for help. And anything the imagination can do to help you, we will always try. So it's a business creation activity, primarily. Also doing some stuff to help recruitment. And we're also always on the lookout for new ideas. And we do have a few cooperations with selected universities on research programs. We've got one going on with the University of Surrey, for example, in 5G. And we've also got a number of collaborations with universities to develop teaching materials. So there's some research activity as well. Next slide. So what are these teaching activities that we promote? Well, the first one you know about very well. That's what the subject of today's workshop is, Introduction to Mobile Graphics. That is available in 5 languages, including simplified and traditional Chinese. And in fact, we have a policy of making all our materials available in those 5 languages. Why? Because they're actually the biggest markets for us. Most of Imagination's customers speak one of those 5 languages. So I don't need to tell you more about this course. That's what you're studying today. Let me tell you about 2 other courses. One of them comes under the generic name of Vr Fpga. It's all about RISC-V. Some of you may be aware that Imagination has been making a big investment in the development of RISC-V CPUs. So Imagination is growing from being a GPU and a neural network accelerator company to having the full trio of compute elements: CPU, GPU, and neural network accelerator. And our first product in RISC-V was actually these teaching materials. Our second product will be our own CPU design called Catapult. And we've already announced some details about that. And the first shipment of that IP, so the design of that processor, will be shipped in the next quarter. So we're very close to beginning to providing CPU solutions. Why have we entered the RISC-V market? Well, 2 reasons. One, we want to be in CPU because it completes our offering, makes us more competitive with companies such as ARM having all those solutions. But also, we see RISC-V as being a revolution in the CPU market. I'm happy to talk about this separately if any of you are particularly interested. RISC-V is a unique opportunity in the CPU market. It's a big discontinuity. There are hundreds of thousands of developers around the world now who've picked up RISC-V and are racing on with it. So it started off at the very lowest level, very simple embedded systems. It's now already in prototype high-performance computing applications. And I believe that in the next 2 or 3 years, RISC-V is going to permeate every level of computing. So this is one hell of a change. You know, if you think about the old world, there was Mips, then there was ARM, and of course there's been Intel and x86. They've been the dominant processor architectures. Well, RISC-V isn't just the new kid on the block. It probably will become the dominant architecture, certainly in embedded processors in the next few years. That's how big it's going to be. So Imagination is moving into a market that's growing very fast. What we bring to that is that we're very good at verifying designs. So some companies are coming to us and basically saying, we'd like to use RISC-V. It brings some advantages for performance, power consumption, lower cost, but we need to be sure the design will work in production. It needs to be fully verified. And we know that you, Imagination, have a 20-year history of making proven and reliable implementations. That's what we can bring to the party there. So we have a course all about understanding computer architecture. Some of you may remember we had a Mips course called Mips Fpga, which was the same kind of style. We've done the same thing with RISC-V. We've actually used an open source core called the Swerve, S-W-E-R-V. That was designed by Western Digital. They use it in SSDs. We use it inside our GPUs as well. So when you're using our latest GPUs, the processor that does the housekeeping in the GPU is a RISC-V. It's actually a Western Digital RISC-V that's open source. We've built an entire course around this. It's 2 semesters worth of materials and 20 labs. It's written by the team that did Mips Fpga. So Sarah Harris, Zubair Kakakel, and Daniel Chava-Martinez, wonderful group of people. They've put together some brilliant materials. It's available in 8 languages right now, plus another one, Portuguese, on the way. And these extra languages, where have they come from? They're people who said, Robert, we really like these materials. We're happy to translate them. We'll do it free of charge. Now, we give a gift, but some of these extra languages have been simply the enthusiasm of users wanting to get these materials into their language. We've got over 1,000 universities already signed up and using these materials. It's been phenomenal. The workshops in Las Vegas are on the 20th and 21st of May, and they're on this subject given by Sarah Harris. The good news is Daniel Chava-Martinez will be here in London on the 4th and 5th of July at Imperial College. So we have Vr Fpga. We've just opened the registrations for this. So it's Imperial in Kensington, not far from here. And that is 4th and 5th of July. Okay? And there'll be other workshops elsewhere in Europe coming up. We're going to 2 other locations in the States, including Rice University in Houston. We have a program of workshops in China at 5 locations, in plan but on hold for reasons that all the Chinese would know very well, but that will go ahead as soon as we can. So understanding computer architecture is a very big, very popular course, and we're achieving a lot of profile of this. There's a sister course to it, which is another semester, which is in 5 languages, which is an introduction to SoC design. So in essence, what this course starts off by doing is saying, okay, you know a bit about digital design. Let's show you how to make a processor. Let's look at a processor. How does it work? How do you get data in? How do you do your hello world? Then it goes in depth. How does the pipeline work? What about the memory management? And at the end of that, at the end of this course, most students that are enthusiastic would be thinking, well, maybe I could design my own chip. So we take them through that process. Using an FPGA, let's create our own SoC. And in this example, what we do is we put the Zephyr RTOS onto that core, run a real-time operating system, and we run an example actually doing some AI on it, running a TensorFlow program on it. So 3 semesters worth of materials, the largest and richest collection of teaching materials on computer architecture available today. And what's really cool is it's on RISC-V, so it's absolutely up to date and of the moment. Following that, we've just gone to trial of an Edge AI course. The struggle here is to have a suitable platform that's using our IP. And we've used, in the trials, we've used a board called the Pumpkin board. We will be moving shortly to a different platform that'll be easier to get hold of. And there's 15 universities currently running this trial. In fact, I saw some questions this morning on the forum about that. And this course will be released publicly probably July or August. And it's intended to be the fundamentals, the basics of AI. You know, what is AI? What's Edge AI? What are the most popular algorithms? Let's run some examples. So it's a start here for undergraduates in AI and Edge AI in particular. So these materials later this year. And I expect over the next couple of years, these materials will go through several revisions and expansions, largely dependent on the availability of newer platforms with different mixes of IP. So you can see how these courses map to the areas that Imagination is growing its business and producing products for. And we do other things to support that, like, you know, this workshop series, the Vr Fpga workshops. We have a sort of side project called Fun with Beagle, which is about running graphics on the Beagle board, based very much on today's course, but also doing something with OpenCL, Open Compute Language, on the Beagle. And for those of you who are maybe new to RISC-V and don't know what it's about, on our website, you can, if you're registered, you can download, without any approval required, you can download a guide to RISC-V, and that explains, you know, why is there such a fuss going on? What's different about RISC-V? That guide explains it very well, and it looks at some popular implementations. Next slide. In order to produce a set of materials that are suitable for teachers, there's 4 key factors that must be addressed. And I want you to know that we understand what your needs are. The first thing is there has to be a suitable hardware platform. And that sounds a very easy statement to make, but actually a lot of hardware is very expensive. And, you know, people say to me, well, you know, a platform for teaching, Robert, what's your specification? I say less than $200. They go, well, that's not a very technical specification. I said, well, no, but it's actually a starting point, because if you've got a lab, I mean, some of the labs I've been to in China, there's 100 workstations. If your board is $1,000, you clearly are not going to be suitable to be used in that lab. Even at $200, it adds up with that number of workstations. So it's got to be at the right price, it's got to be robust, it's got to be easy to get hold of, and there's got to be effective support. So hardware platforms is quite an issue for teaching courses. The right software must be available. And I think you all appreciate that Vr Sdk is free of charge in its full version to anyone who wants it. Not just teachers, but if one of your students really loves the software, they can take it home and they can carry on working at home. Many companies get in a dreadful mess on development software. Even if you only charge a few dollars for development software, you immediately create administration and problems for teachers. I can see you nodding. I've heard this, so I've been doing this a long time. And when I arrived, I worked for a brief time at Arm. And they were in some difficulties. At the time, they had a code size limit. So their microcontroller development kit, if you got to a certain size of program, it stopped working. That's not very helpful, because just as the students are really getting into it and doing well, it stops. When I was at TI, they did something even worse. They had a 90-day time limit. And I've lost count of the number of times that students said to me, oh yeah, Robert, TI Code Composer Studio. The night before my project demo, it stopped working. Imagination is not going to get involved in any of that nonsense. You have my personal commitment that anything the imagination gets involved with, the development tools will be free, they will have the right features, no code size limits and no time limits. And for Catapult, the new RISC-V processor we're producing, we're in active discussions with the developers right now about what could be put in the paid-for version, but what must be there for the academic version. The compiler for the paid-for version will probably be a highly optimized, specialized compiler. Actually, as a teacher, you probably don't want that. For the academic version, we'll put in GCC. It's not the most efficient, but everybody knows it, and everybody can use it. So that's the kind of discussion we do. So we're going to make sure we don't fall into that trap. Effective support, you'll see we have a forum, so any questions about today's course, you can post questions on there. I'll usually share them with Darren and ask him if he can answer them. If you've got questions specifically about Vr Sdk, our DevTech team support our specific forum on Vr Sdk, and you'll get a really fast answer from them. So there's effective support. If you hit a problem, I promise you, we'll be able to support you, and that's the place to put the question. And then finally, teaching materials. I have some very simple principles. Good teaching materials are written by academics for academic use. You cannot create teaching materials for academic use inside a commercial company. These materials need to be written in a way that they're comfortable in a classroom for students to understand. They're not advertising, they're learning. And many companies misunderstand the difference between company training, marketing technical materials, and teaching materials. Teaching materials are something special. And at Imagination, all our teaching materials come from specialized academics who know what they're doing in that topic, like Darren does. So I guarantee that the quality of our teaching materials is consistently above what our competitors do, because they cheat. They try and develop them in-house, which just doesn't work. Next slide. And to give you an example, on our Fpga, these are all the people that we've teamed up with to work with on this activity. So I'm very proud of the fact that one of our advisors who advised on the curriculum for this course is David Patterson. And those of you who are a specialist in processors will know, David Patterson was co-inventor of Mips, the very first RISC processor, and he is the inventor of RISC-V. So David Patterson himself is an advisor on this, and we have a team of people in the US, Spain, and here in the UK who've put the materials together. We have contributions from lots of different people, including Western Digital, who designed the core, Imagination funding the program, RIS5 International support this activity. In fact, it's their largest teaching activity that they have in the RIS5 community. Digilant make FPGA platforms, Xilinx, who should be on here somewhere, yep, the Xilinx University program, they support us, they provide the FPGA. And there are training companies like EE-Tree in China, and even Andes, who we compete with in some areas as supporters. They're a Taiwanese IP and processor designer. Next slide. So just to summarize, we've got RVFPGA, which has 2 strands and a total of 3 semesters. We have Introduction to Mobile Graphics, and later this year we'll introduce Edge AI principles and practices, some other guides and so on that are useful. Next slide. And this is just a summary of which versions are available in which language. And you can see how busy we've been taking our materials and spreading them around the world. I'm very proud of this. Some of our competitors have a policy of English and Chinese only. We want to be much more local to people and much more helpful. And we're very happy to publish in different languages. Next slide. Student sponsorships, as I mentioned, like supporting student societies, particularly where we're recruiting a lot, it's very important. Next slide. And we've got some collaborations with some specific universities like Berkeley, where David Patterson is, UNLV in Las Vegas, which is where Sarah Harris is, and obviously University of Hull, where Darren is. Next slide. So in conclusion, you already know this, I think. If you want to access it, you need to register for the university program. Once you've registered, you can request these teaching materials. We are going to overhaul this process. It's not the most smooth of registration and request processes. We're going to streamline it, and we're working on a new site which we'll introduce later this year. But the key thing that lies behind this is that everybody that wants our teaching materials, we want to make sure that they understand there's a lot of work and a lot of money being spent to create good materials. So this shouldn't just be a click of a button, you know, oh, I'll download that. And then someone goes, oh, it's 300 meg. What's in that? You know, by the time you ask for it, you should have a good idea, yeah, I want that. And we would like to know a little bit about who you are and what you plan to do with the materials. And sometimes we get good information, but sometimes we get very disappointing requests where you hardly know anything about who the person is. If you let us know who you are, then you'll get better support down the road, and we'll also make sure we keep you informed. When we update or change the materials, we will let you know. So that's the portal through which you can get access to support and to any new materials. So, any quick questions? So I think it's a good time to break for lunch. If anyone wants a separate discussion, I'm around throughout lunch, very happy to talk. What time do you want people back, Darren?
It's after 1, so should I say 2 o'clock?
2 o'clock. 2 o'clock back here. And don't forget, if you get lost on the concourse, Harry Potter, platform 9 3/4. There you can get home. Thank you very much.